Hello everyone, I'm Paul and today we're solving problem 2845, count of interesting subarrays. So we are given an array nums and we want to return the number of interesting subarrays. So how do we find an interesting subarray? Well, first we need to see which elements modded by modulo equals k. And then we need to take that count and mod it by modulo again and see if it equals k again. Okay, let's see what this means with an example. Well, let's say we have this array here and modulo equals 2 and k equals 1. The first step would be to see which of the values in the array meet the first condition, nums at I modded by modulo equals k. So 3 modded by 2 equals 1 and 1 equals k. So this one is valid. We will use 1 for valid and 0 for invalid. Next, 2 modded by 2 equals 0 and 0 is different from k. So here we put 0. And 4 modded by 2 equals 0 and 0 is different from k. So here we put a 0. And now we will see which of these subarrays here meet the second condition. Okay, so the count of every valid value modded by modulo equals k. Let's see how this works. Let's say we are here and our subarray only contains a 3. So here we have a count of 1 and 1 modded by 2 equals 1 and 1 equals k. So we add to our result 1. Next, we can take this array and the count of the valid elements in this array equals 1 and 1 equals k. So we can add 1 to the result. And we can also take this array and the counts of the elements in this array is also 1 and 1 equals k. So we can add 1 more to a result. In this case, this would be the 3 interesting subarrays and we will return 3. Now, one first approach to solve this could be brute force. But here we have the constraints and we know that nums.length will be smaller or equal to 10 to the power 5. This means we cannot implement a solution in big O of n squared. This means we cannot do a double for loop. So we need to think about something faster. For example, something that runs in big O of n, such as prefix sum. Okay, now let's say we have this array here, modulo equals 3 and k equals 0. The first step would be to check which of these numbers meet our requirement, our first requirement, which is nums at I modded by modulo equals k. First, 3 modded by 3 equals 0 and 0 equals k, so we put a 1 here. Next, 1 modded by 3 is different from 0, so we put a 0. Next, 9 modded by 3 equals 0 and 0 equals k, so we put a 1 here. And next, 6 modded by 3 equals 0 and 0 equals k, so we put another 1. Next, we want to get the prefix sum of these counts. So we will start with a 1, and next 1 plus 0 is 1, next 1 plus 1 is 2, next 2 plus 1 is 3. So whenever we are creating a prefix sum, you need to remember something. Let's suppose we have an array and we are trying to get the sum of the values in this subarray. Now the way to make it with prefix sum is to take the sum up to this value, so this will include all of this, and from here we want to subtract the prefix sum up to this value, which will include all of this. So by doing this we will get this difference Okay, that's how you get the sum of a subarray with prefix sum. Now, with this in mind, let's see how can we solve this. Remember our second condition, which was count modded by modulo equals k. So we will store in our map the count of every prefix modded by modulo. But first we will add to the map 0 equals 1. Now this 0 here is as if we had a 0 here, because let's say we're trying to check if this is an interesting subarray. In this case, we can take the prefix up to this point and subtract the prefix up to this point. And this will give us the sum of counts in this array. And this is the same as saying the sum rightmost element minus the sum leftmost element modded by modulo, and we are checking if this equals k. What this means is we can track at each step the value of the current prefix modded by modulo and store the count of times we see this in our map. And for each iteration, let's say we're here, we are checking if we have already seen the current prefix minus k modded by modulo in our map. And if we have this key in the map, we can add to the result the count of times we have seen this key. Let's start here at index 0. So first we are checking if we have the current value minus k, 1 minus 0, modded by our modulo, which is 3. This is 1, and we don't have a 1 in the map, so our result stays at 0, and we need to add to the map the current value 1 modded by modulo, which is 3. So we add 1 to the map. Now we have seen the 1 times. Now we are checking if we have 1 minus 0 modded by 3 in the map. This is 1, and we have a 1 in the map, so we add this to the result. Now the result is 1, and we continue. Now we are checking if we have 2 minus 0 modded by 3 in the map. This is 2, and we don't have a 2 in the map, so result stays at 1, and we want to add to the map 2 modded by our module. So 2 equals 1. And now we are here, and we are checking if we have already seen 3 minus 0 modded by 3 in the map. This is 0, and we have a 0 here. So we add this one to our result, and now the result is 2. And just to be clear, this means that the subarray from here up to the value we found, which is 0 plus 1, is valid. So this is an interesting subarray. Okay, and next we reach the end, so we return 2. Complexity for this one will be big O of n, because we are using only one loop, and space complexity will be big O of the minimum among n and the module. And this is because we are using a frequency map to store the frequency of every number. And for example, if nums is bigger than modulo, well, this means we can have up to modulo values in our map. And if modulo is bigger than nums, well, we can have up to the number of elements in the array in the map. So now let's go with the code, and hopefully you will get the idea. First we will create a map with a default dictionary. and initially every value will start with a 0, and we'll add to this map the 0 with a count of 1. Next, our prefix will start at 0 and result equals 0. And now for every number in nums, if n modded by modulo equals k, we want to add 1 to our prefix. So prefix plus equal 1. And we will add to our map plus 1 in our prefix modded by modulo. So map at prefix modded by modulo plus equal 1. And here in between we will say result plus equal map at the current prefix minus k modded by modulo. And here is one big observation we need to make, and it's that if our current prefix minus k is smaller than 0, we want to still be able to check if we have that difference in our map. So here we need to add modulo. Okay, so this is only to avoid negative values. And remember, we are modding this by modulo. So here we could add a plus modulo, etc. Okay, this would work the same. And finally, we want to return the result. This is the entire code, and now let's submit this and see if it works. And as you can see, this works. So if you found this useful, please drop a like, subscribe, and see you in the next one. Bye bye.